Lattice enthalpy. Lattice enthalpy of an ionic compound is the amount of energy required to separate an ionic compound to its individual ions. It means what? Let us take an example. Suppose we have sodium chloride. So whatever the amount of energy we will give this to this particular ionic compound so that it gets dissociated into sodium gaseous ion and chloride gaseous ions, this energy spent on this is called lattice enthalpy. Like in case of the lattice enthalpy of sodium chloride, that we know from experimentation, it is 788 kilojoules per mole. Now what we can simply make out is this, that the stability of ionic compound, let me write it down here, stability of ionic compound is directly proportional to the lattice enthalpy. Now higher is the value of this energy, higher will be the stability of the ionic compound, because that means more energy you have to give in order to break it into its individual ions. That means it's very stable. So that's a very clear-cut direct relationship, and that's why this energy gives us a lot of valuable information regarding the stability of the ionic compounds. We must also know that smaller are the ions, cation and the anion, more closer they will be with each other. So more stronger electrostatic forces of attraction will be having, or they will be having between them. So higher will be the lattice enthalpy. So always remember, the lattice enthalpies also depends on what the ionic sizes. The smaller the sizes, the higher the lattice enthalpies, and it will become more difficult to break such kind of ionic compounds. Similarly, you must also know this time that about certain natures of the ionic compounds. Ionic compounds are crystalline in nature. They have high melting points and boiling points. They cannot conduct electricity in the solid state because they don't have any fixed free ions, but they can conduct electricity in molten or in aqueous state. Also, they are brittle in nature. You can break them into smaller pieces because they are crystalline, they get easily broken to smaller pieces. That's why they are brittle in nature. Another important thing is that these ionic compounds are soluble in polar solvents. In polar solvents like water, because they get hydrated. So they are soluble in polar solvents and they are insoluble in organic or non-polar solvents like benzene, CCl4 and CS2. So these are the certain properties we must keep in the mind, which are the characteristic features of the ionic compounds. And after understanding this, let us move to the covalent bonds.